Hello guys, welcome back to my YouTube channel. So we are going to code a piggy bank contract today. So this piggy bank, anybody can send Ether, but only the owner can withdraw. You know how you're saving, you know how to save, you know how your piggy bank in real life works. You can put money inside, then once you are satisfied of the amount you have saved, then you just have to destroy it to be able to take your money. So that's how the contract is going to work. You can send money inside our piggy bank contract, then only the owner can withdraw. And if you want to withdraw, you have to destroy the contract to be able to take out your money. So that's what we are going to do. So firstly we create our contract, piggy bank, so we declare our pragma version. So we are going to name our contract. So let's declare an address, which is going to be the owner address. Yeah. So let's set the contract owner to be the owner, the person that declared the contract. So declare constructor owner person to sender. So what we did here, we just set the owner to be the person that declared this contract, and the person that declared this contract will be the owner. So let's code a deposit function. So we just did our deposit. It's going to be payable. So let's set our owner. Let's set our address to be payable. So we are setting to payable because we are going to receive Ether. Payable. So the sender. Then let's code our withdrawal. Sorry, our withdrawal is not payable. So we call our receive function. External payable. So let me explain real quick. We declare our address to be payable and owner. This will store our address of owner. So in our constructor, we set our owner, variable, which is an address. We set it to the person that declares the contract. So we did a deposit function, which will be accepting Ether. Payable, we declared it as payable because it's going to be accepting Ether. So we did our function withdrawal, which will be able to withdraw Ether, and only owner can be able to withdraw. So let's code in our withdraw function. So we're going to restrict it not to be owner. This is the sender own. not owner. So what we basically did here is we are restricting this withdrawal function to only owner. If the person that's calling this function is not is if the person that's calling this function is equals to owner, then we will run the code withdraw. But if the person is not owner, we'll throw an error not owner. So we are going to call the withdraw function here. I'm going to go dot send dot transfer control this 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 dot balance. So basically what we did here is that we are telling we are calling this withdraw function to transfer the balance of address this, because immediately anybody calls this deposit function, it's going to send the ether that was deposited. It's going to be stored in this address, this, which is our contract address. So we are basically telling this function to transfer all the ether in the contract, which is our address, this, to the owner. So that's for this. So let's do another require statement. It's the address this dot balance greater than 0. This makes throw an error is so we finish balance. So what this requires statement basically does is to check if the balance of the contract has Ethereum to send. If the balance of the contract has Ethereum which is greater than 0, then it will run this function. But if it does this, to throw an error insufficient fund. So receive function. What the receive function basically does is that it allows the contract to receive inter. You can send that to this contract. If there's no receive function, then this contract cannot send. You cannot receive inter. So I think that's all for PiggyBank. Yeah. Then we want to code a function to destroy the contract immediately the Ethereum has been sent. So we are not going to be using this basic transfer anymore. We're not going to be using this basic transfer anymore. We want to destroy the contract immediately the Ethereum is being sent. So what we're going to use is what we call self-destruct. So we are going to call self-destruct. So this self-destruct takes in one parameter. So the self-destruct takes in one owner, which is the address is going to be sending the ether in the contract to. So once the withdraw function is called, it will call the self-destruct function. And once the self-destruct function is called, the contract is going to send this ether in the contract automatically to the owner and destroy the whole contract. So let's deploy and see what we got. So PiggyBank deploy. So let's deposit 10 ether. Deposit 10 ether. You can see it automatically shows on our balance that we have 10 ether. That's the contract balance. So let's try and use another account to withdraw. Let's see. See, it shows an error, not owner. So our required statement is working. So let's try and withdraw. See, our balance was 89 ether. Our balance was 89 ether. So let's try and withdraw. Our balance is 99 ether, and our contract has been destroyed. Any transaction we do now is invalid. So let's try and deposit the ether to this contract. You can see it went. So let's try and withdraw. You can see it's not working. Our balance will remain one. Anything you do after the self-destruct was called is on your own risk because it's not going to work. Nothing is going to work.